Hey, hello, welcome back. Today we're going to be messing with Unity, which means that we need some stuff first, and that stuff is going to start with Unity itself. Let me post the Unity download link here. I'm going to be using 2019 because that's the last version that I have a license for, and there's really no reason for me to upgrade. I also don't upgrade because I'm afraid it's going to murder all my projects, so I use... let me tell you. I'm going to have to launch it to find out. I use 2019.3, gotta put it next to my other screen. 2019.3.10 is the version that I use. It's 2019.3.10. So mine's a little under a year old. It's actually released in 2020. You can download 2020 as well. It'll work fine. The most recent version of 2020 that I recommend is probably like the last of the 1.0s. I usually don't recommend... Well, you could get the very last 2022, actually. That'd be fine. I usually don't recommend getting the most recent. If you go to their website and download it directly, they'll want you to get 2021 probably if it's out of beta. There's usually a few kinks to iron out in the earliest versions of every Unity release, so I usually recommend sticking with the last generations until they iron out the beta kinks. So given that 2020.2.3 released 5 days ago, I'm guessing that 2021 is probably still in beta, so this is probably the most recent. And given that, unless you have a compelling reason to need 2020, I would really recommend sticking with the 2019s, which have had more bug fixes. You'll notice that that released 8 days ago. So Unity continues to support, that released 15 days ago, versions of Unity for several years. So it's not like 2019 is outdated or anything. It just has less features, none of which I think we're going to need. The biggest additions in 2020 have to do with fancy new rendering pipelines that don't work that great on mobile anyway. There's also a new system for setting up the mobile version in 2020, if I remember correctly. I haven't tried 2020 yet, so it might look a little bit different than what we do here. Once you've got Unity Hub, all your installs will be listed like this. You can download it directly, or you can download it via Unity Hub here. And if you don't have Unity Hub, it will prompt you to get it. Again, 2019.3.10 is the version I have. Ignore the Fs, the minor versions are always included automatically. You can also add releases, the popular releases, directly from here. Or if you click them in Unity Hub here, it'll actually open in this window. So what you want to make sure that you do during the installation process is obviously check the box for Android if you want to be cross-platform and develop for iOS as well. It's not that difficult. I'm not going to bother because I don't even have an iPhone here to test on. I don't even want to drive to John Carroll to grab mine, so I'm just not going to bother. But if you want to test on your iPhone as you go, by all means. And check the box that says Android, and also check the build tools, the SDK and the NDK. Make sure documentation is checked as well. That's by default. And then proceed with the install. So make sure that the Android and the build tools and the NDK are all checked. Now, if you are a miser for your hard drive space and you don't want to download the SDK again because you're astute and you realize you just got it for Android and it's literally just going to be a copy, you are actually able to use your existing SDK that you just downloaded for Android Studio in Unity as well. I'll show you how to do that. Why did I just close Unity Hub? Well, bring that back. Okay. And then I'm going to create a new project. This is the screen that you see when it's time to create a new project. But before we do that, I'm going to do something a little bit extra. So the only way to run applications on your Android device from Unity is to build them. And building takes like, I don't know, 30 seconds to a minute. Building takes a pretty long time. And that's a long time to get feedback on a game that you're working on. You definitely want faster feedback than a minute or 30 seconds or whatever. So what you want to do in order to test your game quickly is to download a piece of software that is borderline magic in the way that it works. You can get it from the Play Store. It's called Unity Remote. So on your phone, did Play Store just crash? That's great. Go to Play Store and search for Unity Remote. Is my Play Store seriously crashing? This is awesome. What the heck is going on? You know what? It probably was running in the background, and it didn't like that. Let's try again. Unity Remote. All right, great. So it's the top one there, the one with the Unity logo, the cube. So we'll go to that one. Unity Remote 5, Unity Technologies, APS is the official company. It's going to have, so how do I get to it? It's going to have a bunch of 3-star reviews because it's been a piece of junk since it came out, and it always will be, but it definitely works for what it's intended to do. It's got about 100,000 downloads, about 3.5 stars. So download that. You'll get to, once it's installed, a screen like this. And make sure your phone is obviously connected via the USB cable. Make sure your phone is connected to the same network as your computer is, so same LAN, either network cable to your computer and Wi-Fi to your phone, or both of them on Wi-Fi or whatever, but I'm pretty sure they have to be on the same LAN or this thing won't play nice. And then we'll see in a minute what the Unity Remote enables you to do. So this is going to be Tic-Tac-Toe Unity Edition. And I'm going to make this a 3D project. Now, you get to choose at this point. You get to make a big choice. You get to choose whether you're going to use the legacy renderer, which are all the top options, or the fancy new renderers. All of you will probably use the legacy renderer because using the fancy new ones is a lot of work, but the fancy new ones support things like ray tracing, which isn't in phones yet, so that doesn't matter, and other cooler features. But the legacy renderer looks fine, and most games are made in it, and most games look fine, so just roll with that. Let me do a poll and see how many people have Unity installed. You don't have to follow along with me today. You can just spectate and see if it's something that you decided to engage in. So just a few people. If you already had it installed from a previous class, I'm going to take a separate poll. Already had it installed from a previous class. This is the hard setup. If you've already had it installed, then you can't easily get the build tools. So you either need to, if you already had it installed, you need to download the, so for my package, which is 3.10 for example, you would need to download the Unity installer and check the Android build tools there. And then you're going to have to manually add them to your project. So it might be easier if you don't want to go through the trouble to just go ahead and reinstall or install a new version. And you don't have to have the same version as me, but if you want to follow along exactly. Anyway, so Tic-Tac-Toe Unity Edition, 3D game, because we're going to practice some 3D stuff. Yeah, yeah, it was kind of a chore for me to set up that Android build stuff, so I just recommend reinstalling. Now, the good news is you can reinstall directly from Unity Hub. If you go to that bottom tab on the left, you can say add, and you can just add a new version of Unity, and then it'll go through all the checkboxes with you and do all that. The bad news is it takes like 10 plus gigabytes for every version of Unity that you have, which is a lot. It adds up pretty fast. Which is why I don't want to install another one, because I've already got like 3. In addition to what it says in Unity Hub, I have others from before Unity Hub and all that, so yeah, no thanks. Alright, so this is how you start. That's a blank. First thing we're going to do is I said that I would show you how to add the existing Android tools in case, again, you're stingy on your hard drive space. You don't want to install them twice because I guess why would you? So go to Edit and Preferences. You'll come upon External Tools. External Tools on the left. So Edit, Preferences, External Tools. You will uncheck using the JDK, SDK, and NDK installed with Unity. You can keep the Gradle installed with Unity because I think it comes with it if you just got the Android tools. Gradle is ridiculously system hungry on all platforms, not just Android Studio, but Unity does a pretty good job of forcing it into the background. And the best part is that Unity doesn't do a Gradle build until you actually fully build your application and deploy it, which means that Unity builds super duper fast by comparison because it only does editor builds. The downside you're going to see is that it runs in Crapovision, but that's fine when you're just testing. Anyway, really cool thing about Unity, because remember how long those build times were in Studio. Alright, so you've unchecked those boxes. We're not going to use the NDK. I doubt anybody will use the NDK. The stuff it's used for, yeah, I doubt anyone will run into it, so if you don't have it, fine. I put my Android tools in a smart place because I'm used to having to find them. If you use the default install directory for Android, God help you, it's somewhere in app data local, so you're going to have to go to Windows and do %app data % and then find it wherever the heck it is in there. I think it's under app data, your username, local, Android, system tools, something like that as the default, so forget that. You can use, I'm actually using the JDK that came with my old Eclipse install, so it's a Java JDK, it works, whatever. I might run into problems with it later, I might not. I think it'll be fine for what I'm doing. So I'm using the JDK that came with my Eclipse install, the Adopt Open JDK, and the Android tools that came with my Android Studio install. Or again, just spend the extra 4 gigabytes and download the ones that come with Unity and never have to worry about it again. Hopefully. And that's it for that. All right. Next, we're going to go to File, Build Settings. File, Build Settings, because the default will be the PC. So we're going to go to File, Build Settings, and change it to Android. We're going to build on Android. As soon as we hit the Switch Platform button here, it's going to do a bunch of stuff. The more you had done in your application up to this point, the longer this process would take, but at this point, it's pretty quick. And the main thing it did was that it changed my preview window, which I'm going to change to what the default will be for you guys. I think it's probably defaulted to 1280 by 720 portrait mode, I think. Okay. And if you wanted to build your app completely and deploy it to the phone, so hit this Add Open Scenes button to add the scene that we're currently in to the build that we will be generating. Every scene in your game has to be added like this, and if you wanted to deploy the real version of this game to your phone, you would hit Build and Run here. Let's try that out. First, I'm going to put something in the display. I'm going to add a cube. Don't worry about how I did that, just I added a cube for the sake of having something to show. There's another cube over there. Okay, great, I have 2 cubes. So I'm going to save, and then I'm going to build this to my phone. You can either do that from the Build Settings menu, or there's an option directly under File. I'll put that in the folder where it asks for Tic-Tac-Toe Unity Edition. Usually you'd give it a version name or something. And because I used an outside SDK tool, it thinks that it's version 0. I don't know how to fix that bug, so I just hit use highest install and it'll figure it out. Okay, now back to my Android device for a moment. Let's see what happens once it's done building. And also, set your timer. Let's see how long this takes. It takes a very long time to do a full build. And that's with a blank and nothing in it. Once you actually start putting stuff in it and doing shaders and stuff, you can easily reach the like half-hour mark for a build. Usually I don't get over like 2 to 3 minutes, but it can get pretty big pretty fast, especially if you do a lot of lights and shadows in your scenes. But notice the Gradle step only happens when you do this full build. La la la. So now it's copying the APK to my device, which it was able to identify. I get the Unity splash screen, and I got 2 cubes. Woo! Alright, looking good, looking sharp. I got 2 cubes there. Okay. I'm going to close that. Lovely. Alright, so that was a full build. Normally you're not going to do a full build. That's only when you're ready to deploy it to the device or when you want to do some final testing with a complete device, like you want to see the full graphics and everything. Normally you're going to run it in the editor, and when you run it in the editor, it runs in this little game window here, but you want to be able to see it on your phone, right? And that's where the Unity remote comes in, if it works. My experience with the Unity remote is basically 50% of the time, every time. So let's see how it does today. Follow the directions that it gives you. Edit, project settings, editor, device, any Android device. Resolution, downsize works fine. Normal doesn't really look much better in my experience. You can give it a shot if you want. Everything else is fine. Okay, so I've changed those settings and I quit. And now I'm going to run it on in my editor. And if all goes well, you can see it's now running on my phone too. And there it's seeing the same window as that game preview. So what this actually does is it doesn't build your application. It runs it in the editor. And it just sends a picture basically to your device, and then your device sends its inputs back to the editor. So this can give you a false impression of the performance of your application, because when it's running in the editor, it's obviously using your computer, which is probably much more powerful than a phone. Most of you probably have a desktop. So be aware that the smoothness and everything that it runs within the editor is not going to be the smoothness that it runs within the application. A phone has way weaker hardware than your average desktop, so you should regularly try stuff out in the full build to make sure that it's still like smooth and able to run and everything. Okay. The other thing you'll notice here, I picked the default, the 1280 by 720 mode, and the cubes aren't cubular. They're stretched. They're rectangles. They're not perfect squares. And you know how obsessed I am with perfect squares, right? So look up your phone and make sure that your editor preview matches the aspect ratio and the resolution of your actual device. So in my case, the OnePlus Nord actually doesn't have a 16 by 9 or an 18 by 9 screen, which is what all the options here are. I actually had to add a new one and specify that it was 9 by 20 because the Nord's resolution is actually 9 by 20. If I do that and run it again, then you can see that now that I've chosen an appropriate aspect ratio and resolution for my device, 9 by 20, now they actually are squares. Okay, so make sure that the preview matches the device that you're using. And then later, of course, you're going to have to make sure that you program everything in proportion to the actual size of the screen that you're on. But obviously, once you build the application, as we could see in the built version, which I'll pull up on my phone here, because it's now installed in my application drawer, actually. It's Tic-Tac Unity Edition is installed as an app, we can see that the cubes are correct. And you can note the difference in sharpness again, see how much sharper these are versus the cubes that I had in the editor version. Alright, so back to the Unity remote. I don't need that open. I don't need that open. Let's see if everybody got Unity remote. Got Unity remote. Yep. And nope. Again, you don't have to follow along today if you don't want to, but I'd like to see how many people were able to get it, because people are always complaining that it doesn't connect. And sometimes it will randomly disconnect, and sometimes you launch the editor and it won't make a connection. You just have to restart. It's not that big a deal. It's wonky. Usually you want to plug the device in, open the remote, then start the editor. In my experience, that gets rid of most problems. Okay, well, we'll keep the 3D cubes there as we do a tutorial of how to move around in Unity. So you got this screen, it's black and gray, and there's a sky. All right, how do we move around? So clicking gives you the selector, which you use almost never, if I'm being honest. And you'll probably never see me use the selecting tool. If you want to pan left and right, you use the middle mouse button. So click in your middle mouse button. If your middle mouse button doesn't click in, or you don't have one, buy a new mouse. No, but seriously, I don't know what you do if you don't have one. You have a bad time, I guess. So middle mouse button gives you the grippy hand to move around. Middle mouse button. To rotate the screen, hold Alt and then left click. Hold Alt and left click to rotate around in the editor. Middle mouse button move. Alt left click to rotate, middle mouse button move, Alt left click to rotate. You can double click on an object in the hierarchy to snap to it, and then maybe we want to spin around it and see, la 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 la. Lovely, and then pan around again. Okay, that's all the important things now that we can move around and click things and select them. So let's look at what happens when you select a cube. You have these arrows, right? So you can move the cube around by using its axial arrows. Lovely. Look at it move in the display of what the game will look like too. Okay, you can also move the cube around by messing with its transform position in the top right corner here. There goes the cube. Okay, so I can just click on one of those values and drag it there. I could also just type what I want. So I want it at 0. Lovely, it goes to 0. Likewise, you can mess with the rotation there. Rotate on 3 axes. You can also change to rotation mode in the editor itself. So rather than doing the bar doodads, you can change to the rotator mode up in the top left here, and then you can rotate it using the UI. I don't do that very often, so we're going to stop doing that. You can also switch to the hand up here, which allows you to pan without using the middle mouse button, in case you don't have a middle mouse button. But seriously, you need a middle mouse button, or this is tragic. Okay, cubes are one of the basic building blocks. How did I make a cube? I kind of glossed over that. So I right-clicked in the hierarchy and went to 3D Object, Cube. You can also go to Game Object, 3D Object, Cube. Those are all options that make a cube for you. Cubes have a lot of properties right as they're created, so we'll go through all of these maybe sometime, but just as a quick summary, so the mesh filter and the mesh renderer are the cube's displays. Those are like its texturing and all kinds of different features about what it looks like. If you change the material, you can change what the cube looks like. So there are a few default materials. Let's have a look. This one is quite dark. So now we have a very black cube. Something called target display. We use the default material. Use a line material. Turn it into the sky. Turn it into a little glowing light. Obviously none of these, except for the default material, are designed for a cube. I will definitely help you with your artwork and stuff in 3D gaming. So if you want to design a 3D game or even a 2D game, I will help you secure your art assets and dealing with making renderers and texturing things and all that stuff. I will walk you through all that and make textures for you if you need me to. I have a relatively decent collection if you aren't too picky. Cubes cast shadows, receive shadows. You can turn those things on and off. That kind of stuff all happens in the renderer. The collider is used for physics purposes. If we run this and we look in the game display or in the editor and we just smash these together. Let me line these up properly to smash them together. Nothing happens, right? Because they don't have a rigid body. They don't have physics. So if you want a cube to have physics, which is going to be something we look at a lot later, we're going to have to add a rigid body to both of them to allow them to be physicsal. And the first thing you'll notice when you add physics rigid bodies to your cubes is that they'll fall down into the abyss forever because gravity, right? Womp womp. So if you don't want your cubes to fall down into the abyss forever, let's create a new cube. And let's scale this cube to be big and flat. Now your cubes will fall onto it. And now they're just sort of stuck there. Now we can maybe move them and smack them against each other. Okay, good times with the Unity physics engine. Whack. Get out of your cube. Whack. Whack, whack. Bye-bye. All right, so we'll do a lot more with the physics engine, obviously, later on, but just as a quick intro there. There you go. So very simple to get some cubes started bashing around. All right, but today we're going to do Tic-Tac-Toe, a 2D application. So we don't need any of this 3D stuff. What we want to do is a 2D canvas with some buttons on it. So a couple other things I want to point out before we get to the UI. You've got a couple objects that start in the scene. There's a light. If you turn off the light or get rid of it, obviously everything is very dark. So, you know, keep your light on. Notice the cubes cast shadows. Again, I could turn that off in the renderer, and then boom, the cube doesn't have a shadow anymore. You could do that to save resources on mobile if you don't need shadows. We can add other lights. Notice the combination of two lights here is very, very bright. You can mess with the intensity of your lights. You can put them in different places and change their direction. You can even add different kinds of lights in addition to directional. There's things like point lights, which make light in a sphere around them, so like a lamp or a candle. Beautiful illumination. You can move that around too. Ooh, look at that. It's like a... Okay. Get rid of that. Okay, but obviously you need a light in your scene for there to be light of any kind. Then you've got the camera. The camera is the key to it all. The camera is what the user sees, what renders to the screen. Cameras are very important. You can have more than one camera. You can switch the user's display from one camera to another. You can have multiple cameras rendering on the screen at once. That's how some people do things like mini-maps and things. But the most basic is the main camera, the actual view of the game that the user has. There are two main kinds of camera. There's the perspective camera and the orthographic camera. Orthographic is better used for 2D kind of games that are in a 3D world, but then you want to be able to sort of have things disappear into the background and stuff. We see an orthographic view, despite the fact that these two cubes are not on top of each other. In the preview, they appear to be on top of each other. And the floor is cut completely, and the hinted shape of the camera is a square. Not going to get into the difference between orthographic and perspective because there's a lot to it. But most of you will probably use a perspective view, unless you're building something like a side-scroller or a top-down shooter, or maybe a turn-based game, or something with a grid. Those kinds of things are usually orthographics. Projections are your traditional 3D games. Yeah, most 3D games, I guess I would say, are perspectives. This is where you can play with the field of view, very important to gamers, right? Everybody knows it needs to be at least 100. I can look at that, it's making me dizzy already. Let me undo that. 60 is the default, which is rather low. Changing the clipping planes changes how far objects go before they disappear entirely. It's another efficiency thing. Occlusion culling allows objects to be behind other objects. You can target eyes if you're using virtual reality. You can target the left eye or the right eye. So in VR, there's two cameras, one for the left eye, one for the right eye. The skybox here determines what happens when the camera sees the infinite ether. So the default skybox that Unity gives you is this sky texture here. You can change this too. I think it's under project settings. I'm gonna lose it now. Fire, no. Well, we'll look at that later anyway. You can change the skybox, and you could also, if you prefer, to have just a solid color appearing there, or nothing appearing there. It would just kind of turn black in the distance, or again, nothing appearing there. But most people prefer to have some sort of skybox that appears once the camera is off into the ether. Okay, so how do you generally make a UI? So if you have a 3D game and you want there to be a flat user interface that sort of lays on top of the user's screen, the traditional way to do it is actually to attach it to the main camera and have it just sort of float in front of the user and then make it visible or invisible as it goes. So I'm going to add a UI element called a canvas first. So I'm right-clicking on main camera or in the ether somewhere in the hierarchy, and I'm going to make a UI element called a canvas first. All user interface components need to live on the canvas. So buttons and text boxes and all these things, they live on the canvas. And I'm going to make the canvas a child of the main camera. So the canvas is now sub in the main of the main camera. So you have this little drop down now. And then I'm going to create a button. So I'll go to UI and I'll go to button. And look at that, it appears in the middle of the screen. Now look at my canvas, okay? It's huge. It's absolutely huge. It renders to world space, and clearly the camera wouldn't see the button way up there where it is, but it does somehow. And the reason that it does is because the canvas renders to the screen space overlay. If you want a more realistic impression of where it actually sits, change it to screen space camera and then drag your camera in as the render camera. Or pick it from the picker here. It'll be the only one in your scene. So drag it, change it to screen space camera and drag your camera object in from the hierarchy, and you'll see that it now resides within your camera's clipping field. You have a pretty realistic impression of what it's going to look like for the user now. So these clipping fields define the edges of the camera as they are appearing in the game preview, and you can see your UI rests inside of it. And you can change things about the canvas now, like how far the plane is from the camera itself. So if we make that smaller, we see it not only shrinks, but it also moves closer to the camera, but its relative size, of course, is still the same, because as it shrinks, it gets closer to the camera, so it looks bigger. Okay, so that's cool. We'll see that this is really convenient for making user interface elements sized to a proportion of the screen size. So let's say I want it to be 25 away from the camera. We'll see that it's moved pretty close to the camera. And the difference between how far away it is what happens to this cube, for example, when it passes behind that. Well, when it passes behind that in the inspector, we see that it also is occluded by the UI in the game preview as well. So we see that as it passes behind it in the inspector, it gets occluded in the preview, right? So if you wanted things to get occluded by the UI further up, you would do it by moving the UI further up. If you wanted things to never get occluded by the UI, well, one way you could do that very simply is just to put the plane very far away. Then the odds of something occluding it are non-existent. So you put it at the very end of the camera's field of view, the end of it's not field of view is the wrong word, but the end of its clipping plane. There are other ways to do that too, but that's the easiest. So let's move ours up. Let's say I do want some clipping. And you'll notice that the scale mode is set to constant pixel size. This is really helpful. We don't have to worry about the units used here. This is kind of like DP in Android, but it's a lot more intuitive. If you want a button to be square, you just set its width and height to the same value. You don't have to do anything ridiculous. Because everything is in relative pixel units relative to the size of this canvas. You can change that if you want some specific stuff like the screen size to be used, but then you have to use the reference, specify the reference screen size and all that stuff, or you can provide a constant physical size. Definitely don't recommend that, so just stick with constant pixel size most of the time. All right, on to the button. Buttons actually come with a child object called text. So the button is actually only the clickable part of the button. Text is its own thing. You can make text on its own too. So every button is just the clickable button and then some text along with it. Some things you can change about the button. So let's say that I want to make a square button as we did in our Android example earlier. So first I'm going to go and create a square texture for us to use. So 800 by 800. I'm going to delete the background. I'm going to make a square. I'm going to make it thicker. Let's go even thicker. I'm going to pick a cool color. Let's pick transparent green. All right, good enough for government work. Let's call that our square outline. Great. And then I'm going to drag square outline into my Unity. I'll make a folder for it. I'm going to call this, let's call it art for now. It's beautiful artwork, so I'll take it from my desktop and just drag it in there. Square outline. Hooray, it's loaded in, but it's all dark and spooky. And if I try to apply it to my button, so let's say that I drag it in there, it doesn't like it. It doesn't like it there. So it only takes sprites. So we're going to change this from a texture to a sprite. And I want the transparency, so when you change it to a sprite, it automatically detects that the alpha is the transparency, which is how PNGs tend to save, and it makes it all clear and stuff. Anyway, now I can drag that in to the source image, and now I have an outlined button. Kind of a janky outline button, but an outline button anyway. So we could do this kind of thing in Android, but it took us longer too. Alright, so I want to get rid of the text probably, but we'll do that later. Actually, let's go to more interesting things like the X's and O's part down the road. Let's see, what should we do next? Yeah, let's go ahead and get rid of the text because our buttons start as blank. First we can pick a text size that we like for when we actually decide to make the text later. You can give it color. So mine was cyan in the X and O example that we did, but that isn't going to be visible against my skybox here since I went and made the button transparent. So I guess I'll just keep it as like a blackish color. You could also give it a material. For performance reasons, we usually turn off the raycast target option, but that's probably too advanced for now. We won't go into that till later. Get rid of the button text, Don't need the text, so I just got rid of the text there. I'll take a quick poll and see if everybody is following me so far, because I'm not seeing any questions. If you have any questions so far, let me know. We've ran through a lot of components really fast, so I ran through text and buttons and all these things very quickly, so I understand if I lost some people. You'll notice that text is not the object itself. Text is actually just another game object, like everything else. Everything in your scene is just an object. And objects all have components, and text is just one of the components that is pre-built into Unity. It has a bunch of properties here. It also has a rectangle transform, which determines where it's going to be. All right, so for positioning buttons, you have this very helpful tool, which you can use to determine what you want your button's pivot to be, which is where it's going to anchor itself on the screen. So this X and Y position is always relative, the X and Y of the transform, and the Z as well, which doesn't really matter in a 2D plane. But the X and Y position is relative to the pivot. So the default pivot is the center point. You can also set the pivot, let's say, to the top left corner. If I set the pivot to the top left corner and then I change the position to 0, 0, the button's now anchored to the top left corner. But wait, it's off the screen. That's not great. So, you know, you're going to have to choose accordingly. I like to have my pivot as the center in general, but there are other situations where, let's say you have a mini-map you want to build and it's in the top left corner, where you're going to anchor that to the top left corner probably. Let's say that you want to set you want a health bar or something in the top right, where you're going to anchor that to the top right corner. And then the position is going to be based on that. If you hold Alt while you set the pivot, it also moves it for you. And if I do it up there, it's going to be smart and figure out that it's a certain width and it needs to go up there into the corner and be that width and not fly off the screen. So it's clever enough to figure that stuff out. All kinds of cool features like that. All right. So that's the pivot, and then you can move the X and Y around accordingly. So I'm going to pivot to the center here because I want my tic-tac-toe board in the center like we had in the Android version. It updates the anchors as you do this, so we see the anchors changing. If you want to make custom pivots, check out how these anchors change as you go for different corners and stuff. You can actually anchor your stuff to any arbitrary point on the screen by messing with the anchor. So if you wanted to anchor something like right there, you could do that. I don't know why you'd want to, but you could do that. Definitely do that. Scale affects it here too, but we generally don't play with scale with UI elements. We change their width and height instead. So 3D objects, we change their scale. UI elements, we don't. Rotation. So if you wanted to make a rotating button, that's a cool effect, right? We've all seen it in like fighting games or something. There's like a rotating trophy or whatever. You can certainly do that by just adjusting the rotation like this. Luckily, UI elements have rendering on both sides. They're not just flat. But some items in Unity don't have that. Some items render only on one side. Probably won't look at those at all, actually. All right, so this is going to be one button. I'm going to need 9 of these guys. So let's make a bunch of these guys. Let's see. Button, 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 button. Well, actually, let's make them in 3s. All right, so this is going to be top left. This is going to be top mid. I'm using F2 to rename them, which is the rename hotkey in basically every software, including Windows. Otherwise, to get to rename, you have to right-click and go to rename. It takes forever, so F2 and the arrow keys. I like to stick to the keyboard whenever I'm not messing with the interface there. So select the object you want, F2, type the name, enter. Okay, so top left is going to be at -50. Let's go with -50 on the Y, or +50 on the Y. Positive is up in this coordinate system. Sorry, people who I educated in the swing. I also get confused with it all the time after I transition away from swing. Okay, so this is my top row. Very nice. And I want to make them all a little bit smaller so you can see their outlines a little bit better. So you can actually change the dimensions or the properties of a bunch of components at the same time as long as they all have the same property. Notice X got this underline doodad because they don't all share the same X. But they do share the same width, height, and Y. And I can change all of theirs at the same time now if I wanted to, 45. So there you go, I've changed them all at the same time. I'm going to change my skybox to black so I can see this a little bit better. Change my skybox to a solid color. Cool. Very nice. All right. So you'll notice it doesn't change in the editor. The editor always sees the default skybox until you change it. I'm going to make the middle row by just taking these three and pasting them, and then adjusting their Y value to 0 as a group. So that was easy. Awesome. Now I need to change their names. So that's mid-left, mid-mid, and mid-right. I'll make the bottom row the same way. I just copy the three middle guys and paste them, and then change their shared Y value to -50. And that's going to be bot left, bot mid, and bot right. Okay, cool. Let's run this and see what it looks like on my phone. Remember, much grainier than it will be when you finally build it. It's only a preview of the game window. It will look much sharper when I build. So I can click these buttons, and they kind of like pulse. The light is really subtle with this background and everything, but it's like a gray pulse. Obviously, you can change that. So my floor is kind of cutting them off. So let's move my floor down a little bit so you can see my whole grid. Let's say I wanted to change the highlight color or whatever. Let's play around with these colors a bit. I'll make that one cyan. I'll make the pressed color red. I'll make the selected color pink. And I'll make the normal color... Look at that. The normal color changes the color of the buttons right now. So if you set it to white, then it will be whatever color that you've chosen in your material. It won't tint your material at all. If you set them to something else, you can tint your material additionally with that color. So let's say I wanted it even greener than my original material was. I'm going to change them to super green. All right, let's run it and see what happens when you pick different buttons now. Let me have that open. Oh, whoops, did I not save any of that? Nope. So what I did accidentally was I changed settings while it was still running. And if you change settings while it's still running, so something like moving the floor or changing button properties, all of that stuff gets deleted when you stop that execution. So that allows you to mess with components as the simulation is running. That's not something you're going to want to do, generally speaking. In order to make persistent changes, because of course they'll be deleted as soon as it stops. So let's go through this again and just pick a few different options. All right, see what these look like in practice. Ah, shoot, I closed my phone. Bring that back. Okay, so when you tap it, see it gets that blue tint from being selected, so the last button you tap gets that tint. If that's something that you're interested in, you also get that little color ripple when it's tapped, which you can't really see because of the white background, but you get kind of that pink ripple. So you can play around with these for fancier looking buttons. Generally speaking though, the UI components that ship with Unity are not used for much. They are pretty bare bones. I'm going to restore all these to white. If you want to make any kind of fancy UI, you will normally go and grab some nicer looking assets or a nicer looking UI system. Okay, let's get to our scripting and code part. We'll add the little text box and stuff later. Alright, so I'm going to create a new folder for my scripts. That's a good convention to follow. Here's my scripts folder, and I'm going to create a new C# script in there. So I've clicked inside my assets script folder, and I'm going to create a new C# script in there. And I'm going to create this script called UI Manager. UI Manager. And this is going to control my button clicks and stuff. And if I double click on this script, it's going to open Visual Studio for me and take me to my scripting page. Now I've configured my Visual Studio a little bit to do different auto formatting things. I don't remember how you make the font bigger in Visual Studio. Options, fonts, 16, there we go. Okay. That works. Oh yeah, you can change the zoom level here, but that's not the same. It gets kind of grainy if you go over a certain point. It's like, well, actually that's fine. I could have done that. Whatever. We'll stick with this for now. But thank you for that tip, and I hate dangling parentheses, so you'll see me do this every time I make a new behavior. And of course I get rid of these stupid to-do steps every time too. Okay, so we're going to want an array of buttons. Let's go with that. Button, oh boy, what did I just do? Button. Off to a roll here, aren't I? So it doesn't see the button class in there. New button. Actually, there's only 9 of them. Oh, having insert off would be helpful. Alright, it doesn't see the button class in Visual Studio. The auto fixer requires you to do this extra click. We're going to be using unity.engine.ui. That's where most of the button stuff is at. So there's our buttons. There's our 9 buttons. I'm going to save this, and I'm going to create a new object in the scene that's just an empty object. This is a convention in Unity. Most scripts, almost all scripts, are going to be attached to an object. I'm a little anal, so I always set my empty objects to be at 0, 0, 0. Don't know why. I'm going to name this object UI Manager 2 because it's going to be the object that has UI Manager on it. And just like all the other components, like renderers and colliders and rigid bodies and images and buttons and all those different things, scripts can also be added to objects as components. You can drag your script onto an object, or you can go to Add Component and find it here. So it'll be, if you can search for it, UI Manager there, or you can find it under Scripts. It'll find it there too. So I've added the UI Manager script to my UI Manager object. What will happen now, and what will happen for every object in the scene, is that it will dig up my script. It will run the start method when the object is first born, in this case at the very beginning of the program's execution, and then it will run the update method every time a frame gets updated. Unity has a cool execution model. Almost all game editors have this. Every single frame, it runs the physics engine to figure out where everything is at. So everything moves up a little bit, figures out its collisions, all that stuff. Then it goes to every object in the scene and runs every behavior script. All of these scripts are called behaviors on every object. Runs their update method, figures out what's going to happen, does all the final calculations of what everything looks like, applies all the rendering that needs to happen, and then sends it all to the camera, and then it renders to your screen. So a ton of stuff happens, and all of this has to happen basically 60 times a second. You don't have to know any of this, but all of this is to say that it's very easy to mess up your program by accidentally doing too much in the update method. Your program has a lot to do. Let's leave it at that. Alright, so after I save this, oops, forgot the keyword public. After I save this, when we go back to the editor, we'll see that I can now add buttons to my UI manager because I have this public array. And if I didn't give it length, it would ask me to specify the size, and then I can add them here. And I can actually just drag my buttons in and link them. I unfortunately can't drag them all, but I'm going to just drag them in one at a time. So that's top mid, top left, top right, there's mid left, mid mid, mid right, bot left, bot mid, bot right. Okay, I've dragged all my buttons in. So let's just do a little loop to make sure. So all of this will seem very familiar to you because C# is almost exactly the same thing as Java. The one difference between Android Studio and Unity is that the print command is debug.log. This connects to the Unity editor and allows you to see the debug output in the Unity editor instead of in Visual Studio. So I'm going to print buttons of I. Let's do that and see if they've all been connected. All right, so save that. Save in my editor and run this. And we can see in Unity's console that all of the buttons got printed. So there's top left, top mid, top right, mid left, mid mid, mid right, bot left, mid right, etc. So that's all of my buttons getting printed out there. And now I need to find some syntax in my notes, so bear with me for a second. Okay, so that's a list of the buttons, and let's see. Let's figure out a way to identify these buttons one from the other. So right now, the only thing that identifies them is their name. That's not very helpful. So I'm actually going to make another script here, and I'm going to call it. Let's call it button ID, and I'm just going to use this script to identify different buttons. So getting rid of all this stuff again because it bothers me to have it. I'm going to add a couple of public fields here. So I'll have a public int row and a public int column. Okay, and let me add this button ID to all of my buttons here. So I will drag it in as a component to all of them. Remember, if I select all of them and make a change, it can affect all of them. So now all of these components have a button ID script. And now I can enter the row and column here as I wish. But let's say that I want to do one better, because there's a limit to which row and columns you can choose from. There is like no row 15 in this example. So let's say that I want to add a little slider bar doodad. Unity lets you do that very conveniently. It lets you link to items in the editor by doing this. This little range command and other commands like it inside of brackets, square brackets, they link back to Unity editor and allow you to have, rather than a entry box, a slider bar. Okay, cool. So top left is going to be 0, 0. Top mid is going to be 0, 1. I still have a text entry here, by the way, and I can enter numbers that are out of range and just clamp them. Top right is 0, 2. Mid left is 1, 0. Mid mid is 1, 1. Mid right is 1, 2. Bot left is 2, 0. Bot mid is 2, 1. And bot right is 2, 2. So that, I feel, is a little bit easier than what we had to do in Android. By allowing us to attach a script like this, we were able to give each of our buttons identity really quickly, which is cool. So now if I loop through all the buttons in UI Manager, instead of printing out their button ID here, let me print out that fancy row and column value that they get from the buttonID.cs class that I wrote. Let me show you how to do that instead. So that row and column value is bound to a particular component on our device. Closing out of my other stuff, I got a lot in my way here. That buttonID thing is bound to this buttonID.cs class. Whenever we want to access a component from an object, we use a method called getComponent. And whenever we want to access the game object that a component is attached to, we can access that as a simple field. So for example, all of these buttons that we made in the array, those actually correspond to these button components attached to the object. Not to the object as a whole, but to its button component. If we want to access the actual object, we would use buttonsOfI.gameObject. That would be the object that is attached to that button script, or sorry, the object that that button script is attached to. All right, now in that object we want to search for, so get component a, and then we use these square brackets, sorry, these alligator brackets to designate the type we're looking for. We want to find a button ID. And then we're going to hang on to that. So button ID equals buttons of i.gameObject.getComponent button ID. So I'm getting the game object that this button is attached to, and then I'm asking that game object to give me the button ID that is also attached to it. So this guy here. Now I can print id.row, I'll do a blank, and then id.column, and just for added emphasis on what GameObject does, let's also print buttonsOfI.gameObject and see what we get from that statement there. Alright, so now to run this again. In the Unity console we get 0,1 is top left, unity.gameEngine.object, 0,1 is top mid, unity.gameObject, and so forth. So we're printing out those object references. Should be very familiar to you coming from Java, but these kinds of complex object-oriented programming statements are going to be all over Unity, so you need to keep that pattern into your head. Every component's attached to an object. Every object has a bunch of components. If I need to access one of those components, I always need to use getComponent. This becomes second nature very quickly. It's really quite straightforward. Okay, let's comment that out for now. Let's see how we set up the buttons to actually do something. So the simplest way to add a listener to a button is buttonsOfI.onClick, and then add listener, and then specify a method name. So the convention in C# as in Java is to use uppercase letters for your method names. So if I had an onClick here, let's say debug.log. Whoops. Hello world. And it was as simple as that. So if I run this again, I can click my buttons in the game screen here rather than clicking them on my phone, and I get hello world. Lovely. Okay, normally we're going to want to do something a little bit more complicated than that, but that was pretty easy. The other thing we can do is actually add them directly in the editor. There's an onClick property to button that you can add stuff directly to, and you have tons of options here. You can affect game objects, you can do all sorts of things in the onClick method here. And when we run this, we'll notice that our thing didn't get added to it. That stuff occurs separately. So this stuff is different, and I normally don't encourage using it because it actually gets more complicated, but people have pulled off some pretty awesome stuff with these buttons and the onClick methods. So up to you if you want to play around with it. Normally we're going to want to do something more complicated than that, right? Normally we want to pass a few arguments too. It's not enough for us to just trigger some onClick methods. So let's go with an onClick. At least we need to get the button's ID or something, right? We need to get something from it. So let's go on-click with args and try taking a few args. Let's say we want the row, the column, and let's say the index of the button in that array, and we'll pull it out of there ourselves. Okay, so that's a little bit more complicated. That's going to require you to use either a delegate or a lambda, which we're not going to go into what those are. They have them in Java too, at least lambdas. I think we have delegates in Java as well, but we've probably never used them in any of our classes. So it starts the same, right? And then there's this extra syntax. Let's see what happens if I just try to say on-click with args. And then I want to say, let's see, id.row, id.column, and then I would be the index. So let's see what happens when I do that. It's going to tell me that there's a problem, can't convert to Unity action, blah, 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 and it doesn't propose a fix, which is a bit annoying. But if you check the Unity documentation for this, it's very good. You'll have to take my word for it, because I don't have time to show you. But all you need to do is create a lambda for it. Did I do that wrong? Let's see. I think I missed a parenthesis. Oh, or did I equals wrong? Yep, there we go. So create a lambda for it, throw away the left-hand side of the lambda, and now you can use it. You could also create a delegate. I won't show you that syntax. So long story short, don't worry too much about the syntax. This is how you get a on-click method with some arguments. Let's try to print these three values, and then I'll show you another little quirk here that's annoying. So row, call, and button index. Da-da-da-da. It keeps printing 9 for me. Isn't that weird for button index? It just keeps printing 9. That's not right. It's supposed to print the index for that button. The other two work, but button index doesn't. And if I tried to use it, obviously that would be out of bounds. So this is kind of a weird quirk with lambdas. Everything that you put into the arguments here needs to be a value that's locked in. So all you have to do, and this is a little bit counterintuitive, is specify the value outside somewhere, and then you can use it, and then it's fine. So we're not going to go into why this is the case. It just is with lambdas, so this is pretty much the only time lambdas will come up. Why? I'm not particularly going into it. So now it works. We got the number we want. So that's 0, that's 1, that's 2, that's 3, that's 4, that's 5, so forth. Actually, this one's 5, and this one's 4, so it looks like I might have added them out of order. Let me check. So that's left, mid, right, left. Oh, my mid is actually on the right, and my right is actually on the mid. Whoops. What's the easiest way to fix that? Should I just move them? Let's go with that. Okay, just moved them. Oh, I did the same mistake down here because I copy and pasted. So that one should be at 0. That one should be at 50. Okay, running it again. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, great. So I want to actually play my Tic-Tac-Toe game. So I'm going to cheat a little bit. I'm going to go back to my Android project. Let's find this guy. Tic-Tac-Toe. App. Source. Main. Java. Tic-Tac. Remember, I had these two lovely activities, classes from my Tic-Tac-Toe. I'm going to create a new script. I'm going to call it Game Manager, like I did back in the Java original. Okay, and Actually, that's a reserved name, so in general, don't use that. But we'll just go through for now. And then I'm going to take my GameManager.java, and I'm going to copy this whole thing in, and we'll see what I need to do to turn it into a Unity script. Now this, I'm not going to have be a mono behavior. This is going to be a regular, plain C# script. So it's not going to be attached to an object because it wasn't attached to an object in my Java version. All right, I can close out of the Java original now. So what is the C# equivalent to static final int? We don't have static final. Instead, we have sealed and const in C#. So a const is automatically static and automatically final. So generally speaking, they're considered pretty much equivalent. So that's going to replace all my static finals. Now I regret not doing find and replace. But it's too late, I've committed. Okay, there is still static though, so Game Manager's cool. And now, how do you declare a two-dimensional array? It's almost the same, but slightly different. Instead of the two brackets, you do a comma. Never really understood why. And then C# doesn't have multi-bracket sets. It has their arguments separated by commas. And that's unfortunately true of any time you use a 2D array. So I'm going to go to find and replace, and I'm going to just quickly replace every occurrence of the brackets with a comma and a space. So let's do it. Look at that. Everything's right as rain. And then I'm going to go and replace the log.ds with debug.log. And of course, they only take one argument rather than two. So there's a reason that many people say that C# and Java are the same thing, because C# is a lot like somebody copied Java's homework. You can pretty much paste it directly and not have much problem with it. Everything else is largely the same. And then going back to how I process my button clicking, I'm just going to blatantly steal that from the other application too, and just make a few changes there. So let's see how I did it in the Java variant. I had a switch statement and some other stuff. Go ahead and just cheat and take all of that. Okay, so what's different? Well, I don't need this weird switch statement for ID anymore because I actually have the row and column mapped. If you'll recall, the Game Manager needs a row and a column in order to update the tile. I mapped that to my button IDs already, so I'm not going to need that anymore. I still need a Game Manager, so Game Manager game equals Game Manager.get instance. That's still the same. Okay, I'm still going to need to check for the win state, so this is going to be the same. I'm still going to need to grab the tile, so let's go with int tile equals, and then it was game.setTile, row, column. We did that, cool. I'm still going to check if the tile was equal to X or O. Of course, we don't have material buttons anymore. We have the buttons that we get from button index, so it would be buttons of I. Now, how do I set the text of a button? Well, remember, text is a component, but it's not a component in the button. It's actually a component in one of the child objects. Remember, text is made as a child object. So for that, you have the utility getComponent in children. GetComponent in children is a dangerous utility because if you have more than one such component in a child, it could certainly be an issue. So a dangerous one to use, but I will use it here nonetheless because I know that we only have one text object. And that would be the blank variant. And then we're supposed to update the display, which we haven't made yet, so that'll be a later thing. But let's run this and see if we can play our little tic-tac-toe game already. Of course, I can play it in my little mini display here. You can see them pop up, but then you can't see them here because I made the background black like a dummy. And then here I'm doing it on my phone too. Wonderful, we have X's and O's. So next time we'll finish this up and then do some 3D stuff. Let me know if there's anything in particular that you're interested in seeing. And after that, you'll make the decision about whether or not you want to continue on your project in Unity or if you want to do it in Android Studio. I realize that these crash courses have been really curt and we didn't cover a lot, so keep on generating questions and thinking about what you want to do, and I'll see you next time.